Hello. So this is a video on derivations with negation. So take the sentence, it is not the case that Bob is not an emu. Now suppose that that sentence is true. Well, this sentence is the denial of Bob is not an emu. So if this sentence is true, what it's a denial of is false. And since this is the denial of Bob is not an emu, it means that Bob is not an emu is false. If the first sentence is true, then what it's a denial of is false. It's a denial of Bob is not an emu, so Bob is not an emu is false. Now suppose Bob is not an emu is false. Well, the only way that could get to be false is if what it's a denial of is true. And it's a denial of Bob is an emu, and that means that Bob is an emu is true. So, suppose it's not the case that Bob is not an emu. Suppose that sentence is true, then the sentence Bob is an emu is true, no matter what. So this is a valid inference. And we can infer in the other direction. So take Bob as an emu. Well, suppose that sentence is true. That means Bob is not an emu is false. Bob is not an emu is a denial of Bob is an emu. If the original sentence is true, the denial is false. So now we say Bob is not an emu, and we deny that. We say, no, that one's false. And we form the sentence, it is not the case that Bob is not an emu. So Bob is not an emu is false, and that means the big it is not the case that is true. And so we have this is a valid inference. If Bob is an emu, whenever that sentence is true, so is the big it is not the case that Bob is not an emu. So we have these two inference patterns. It is not the case that Bob is not an emu, therefore Bob is an emu, and Bob is an emu, therefore it is not the case that Bob is not an emu. They're both valid whenever the premise of either is true, so is the conclusion. And in fact, the sentence Bob is an emu and the sentence it is not the case that Bob is not an emu, these are equivalent. They say the same thing, more or less. They say it in slightly different ways. One says it in a longer way, one says it in a shorter way, but they're equivalent. And how do you know they're equivalent? Because of your understanding of the word not. Remember, think back to that guy Joe who had the winning lottery ticket, but he couldn't figure out that he did because he had a logic block. Well, if you had a logic block about not, you wouldn't be able to recognize either of these inferences as valid, but you don't. You don't have a logic block about not, and so you can see that both of these are good inferences. Whenever the premise of either is true, then the conclusion of that one is also true. So this is again one of these sort of perhaps very obvious but fundamental facts about how not works. Now, suppose you're in a derivation in our formal system, and you have negation, negation, p. Well, that's the same thing as it is not the case that Bob is not an emu, and so we can infer p from not p, for the same reason that the inference in English is valid. Well, we call this rule double negation elimination. Why? Well, because there are two double negations, and we're getting rid of them. And so we could, if we wanted to apply this rule, write DNE for double negation elimination. But we can also just write DN for double negation. And so you can write DN, or the longer DNE. On the other hand, if you have P, then you can infer to not P. This is another valid inference pattern. This one is called double negation introduction. And why is that? Because we're introducing a double negation. And so you can write DN or you can write DNI. Sometimes you would be able to apply either of them, and if you just write DN, the program will ask you, well, which one of these do you want to apply? And that's why we have DNI and DNE. But you can always just write DN and not worry about the E and the I if you so choose. It's entirely up to you. So we now have three rules in our system. We have the modus ponens rule, MP. We have double negation elimination, DN or DNE. And we have double negation introduction, DN or DNI. And here in these rules, I put circle and square to emphasize that it doesn't matter what circle is. If circle is a sentence letter, this works. If circle is something bigger than a sentence letter, it works. So for any sentences, circle and square, any sentences whatsoever, these patterns are valid patterns, and we can use them as rules in our derivations. Now you want to memorize the rules. It's really important to memorize the rules. If you don't know the rules, then you can't use the derivation system, and you won't be able to do the derivations. And it's helpful to think about the rules in two different ways. One is to understand why the rule is a valid rule. And so I just previously explained why the double negation rules are valid. And so you want to understand why is the rule valid. But you also want to just know what is the rule. And in fact, computers are basically logic machines. And they don't understand the rules, but they're able to apply them without that understanding. And you also want to be able to do that. You want to know just what is the rule? What does the rule look like? When can I apply it? When can I not? Without worrying about why is it valid or not. So there are really those two things you want to understand. What is the rule? What is it? What does it look like? What are the premises? What's the conclusion of the rule? And the other thing is, why is it a valid rule? Two different things. You want to understand both. And there will be situations for every rule, there are derivations that require using that rule. There are lots of derivations where you don't have to use all of the rules, but for every rule there are at least some derivations where you have to use it. There are no redundant rules, so you need to memorize all of the rules. And we'll be adding more, but right now we just have these three: modus ponens, and then the two forms of dm. You want to memorize all of them. If you try to get around that, it won't work. And you also, this is where we want to remember that this is really, it's actually very simple. There's nothing deep or mysterious or magical about all of this. It's just right there. And so what you need to do to master the derivation system is just know what those rules say. We go back to that previous slide. What do they look like? And if you know what they look like, then you can use them. And that's all that's it. It also helps to understand why they're valid, but that's all there is to it. There's nothing more mysterious beyond them. So later, we will add another negation rule, and it's more powerful and more interesting than the double negation rule. Because P and not P say basically the same thing, you might think, well, what's the point of negation? You just have two different ways of saying the same thing. Why would you have negations? Well, we also have single negations, so we have not P. We don't have any rule where you think, well, okay, how do you use not P? Well, you could put two more negations on it, but that wouldn't do anything interesting. So why do we have negation in our system? Well, we'll be adding actually several more powerful, more interesting rules that involve negation. One that involves just negation, and next unit we'll be adding a rule that involves negation and the conditional. So we'll be getting to that. But for right now, we're just going to learn double negation. And so our derivations are going to have a slightly different structure now. We're still going to have the same beginning. We're always going to say show, and then we're square or box is the conclusion. That's what we write. And then we put in more lines. And each subsequent line is going to be one of two things. It's going to be a premise, or it's going to follow from an earlier line or lines by, well, it was modus ponens, but now it can follow by either modus ponens or double negation. So that step where we apply the rules has gotten a little bit more complex, because we're going to have to look not just for applications of modus ponens, but also for applications of double negation. And eventually we'll get the conclusion, and then we will still apply DD, and we'll be done. We will have we'll get to cancel the initial show line, and we'll get to box the derivation, and we'll be done. So that's good. So again, show the conclusion, enter the premises, apply MP and now DN if you need to, and you get the conclusion on a line, and you're good to go. And then you'll box and cancel with direct derivation. And in another video, I will illustrate derivations that work this way, that involve both MP and DN. You'll find it useful to watch that video. If you have any questions, please let me know.